Okay, question number 10. We have 3 parts. First, we want to use Descartes' rules of sign to determine the possible number of positive and negative zeros. And then we're going to find the lower bound and the upper bound. And then we'll actually find the actual zeros. So, this polynomial is g of x, which is equal to x cubed minus 5x squared minus 5x plus 25. Okay. You take the last number in the leading coefficient, which is understood to be a 1, and we're going to divide those factors. Actually, I'm sorry. That's the possible rational zeros. We are looking for the number of sign changes. So let me also do g of negative x. So remember, with g of negative x, you only change the sign of odd degree terms. So this was positive, so when I do g of negative x, it will be negative. And then even degrees will stay the same. This will change signs. And this does not have an x, so it will stay the same. Okay, so the number of positive sign changes, what they mean when g of x is positive, from here to here is positive to negative, so there's one change. Negative stays negative, and then negative to positive, that is another. So there's 2 sign changes with the positive. So you either write 2 or you decrease that number by an even number. So divide minus 2 will put you at 0. And then the number of sign changes for the negative one. It's negative, it stays negative, and then it goes to positive. So there's 1 sign change here, and then it's positive, it stays positive. So there's only 1 sign change. So with the number of sign changes, for positive we have 2 or 0, and then on the negative we have 1 sign change. All right, so the next part, we want to find the upper bound. So you can really pick any number you want and then just backtrack, but just be careful because you might do more work if you skip and go too high. So what we're going to do is going to do synthetic division, and we're going to pick positive numbers to find out which number will give us positives on the last row. So we got 3, 2, 1, 0. We're not missing any terms. For this example, I'm just going to start out with 3, and I'm going to go up from there or go back down. So I'm going to start with 3. I don't want to start too high. I'm going to start with 3, and then my leading coefficient is 1, and then my next term is negative 5, and then another negative 5, and then 25. All right, so you always bring your first term straight down, and then 3 times 1 is 3. When you combine these, we get negative 2. Okay, so that's my problem right there. I need the whole bottom row to be positive, so I can stop here. Now, since I'm multiplying my first term times 1, putting a 4 here is still going to give me a negative. So the first thing I can do to get a positive is use the number 5. So I'm going to try 5. So I'm going to use my same coefficient. So I'm going to try 5. And I'm thinking 5 will not work. Maybe have to go to 6. So 5, we have 1, negative 5, negative 5, and 25. All right, so bring the 1 straight down. 5 times 1 is 5. Combine these, I get 0. 5 times 0 is 0. When I combine those, I get negative 5. So 0 could count as positive, but this is negative, so 5 does not work, so we're going to go on and try 6 now. So if I try 6 with this same problem, -5, -5, and 25, I believe this one will work. Just kind of looking ahead and doing a little mental math. 6 times 1 is 6. Combine those, that will give me a +1. 6 times 1 is 6 again. Combine those, I will get a +1. And then 6 times 1 is 6. Combine, I get 31. So the whole bottom row is positive. This is the first positive number that you get to. That will give you all positive on the bottom. So 6 is your upper bound. So I'm just going to put UB for upper bound, and that is 6. And now we're going to try to find the lower bound. So lower bound has to be a negative number. And again, I might just start out with 3, but I'm going to do -3 because it has to be negative. And what you want is your signs to alternate and change signs each time. So 1, -5, -5, and 25. For my coefficients, bring down 1, and then we're going to do -3 times 1, -3. Combine, and we get -8. All right, -3 times -8 will give me +24. Combine, and we get +19. And then -3 times 19 will give us a -57. And when we combine those, that gives us 25, half of 50, 32, negative. Okay, so it alternates positive, negative, positive, negative. Okay, but since this is the first number I tried, let me make sure that -2 doesn't work, because I want the first negative number when you start going. So -2, we're going to try -2. 1, -5, -5, and 25. -2 times 1, -2, combine, -7. -2 times -7, +14, combine, and we get a +9. And then if I do -2 times 9, we get a -18. And when we combine those, we get a +7. Okay, so positive, negative, positive, positive. So 2 would not work. So 3 just happened to be the right number, and it works. So my lower bound is -3. So what that's saying is that all of your real zeros will be between +6 and -3. So you won't have any zeros outside of that range. And furthermore, if we did the possible rational zeros, which is what I was starting to do, 25 over 1, and the factors of 25 are 1 and 25, and then 5 times 5, I think that's it. So, and then the bottom is 1. So when you list the factors, you have positive or -1, positive or -5, and positive or -25. That means you wouldn't even have to try 25 because it's out of the range here. You wouldn't have to try -5 because it's too big. So the only numbers that you would actually have to try doing synthetic would be 1, -1, and +5, because those are the numbers that are in between this range. So either these numbers work, or it might be another number that's just irrational. So, but there'll be real numbers between 6 and 3. So from here, you can either guess and check with synthetic division. I want you to use the calculator. can't remember if I've shown this or not, but you can use the calculator and find pretty close, and then you'll know which ones to try. So let me put the upper bound and lower bound in. Upper bound is 6, lower bound is -3. And then the next part, we're going to find the zeros. So here's a method that will help you get there pretty quickly. And you can do this at any stage, really. Let me minimize all this real quick. Okay, so calculator, what you can do is we're going to type in this equation to y equal. So I'm going to type in x to the third. I'm going to arrow over to get down, and then minus 5x squared minus 5x plus 25. And then we're going to graph it. And then here it looks like it's just to the left of 2. It doesn't go right through that tick mark. And this one is just to the right of 2. And then, so we got 1, 2, 3, 4, 5. It looks like it goes right through that point on 5. Okay, so what I'm going to do is I'm going to do synthetic division with the number 5 and see if it comes out to be 0. So I already kind of started with 5. I can just finish right here. I just stopped when I was doing the upper bound because I noticed the whole bottom row wasn't positive. So I'm just going to pick up right here where I left off with the number 5. So here's your synthetic setup. Bring the first number straight down. 5 times 1 is 5. Combine, you get 0. 5 times 0 is 0. Combine, and you get -5. So now 5 times -5, -25. Combine, and you get 0. So the fact that I got 0 means that this is a factor. So down here I'm going to say x equals 5 is one of my zeros. And then the resulting polynomial I'm going to write down. So remember, this started x to the third degree. You dropped a degree by 1. And so we're going to start with x squared. So this is 1x squared. And then 0x and then -5. And you set it equal to 0 to solve. So you add 5 to both sides, and that's going to give you x squared is equal to 5. And then you do the square root of both sides to solve for x. And that gives you x equals positive or negative because you took the square root of 5. So as you saw on the graph, it matches up what we came up with when we did the lower bound and upper bound. So we'll go back to that graph. You can see that all of those zeros are between, so -1, -2, here's -3. That number goes just between 2 and 3, but it doesn't go past 3 on the negative side. So that's what they mean lower bound. It's the I guess the smallest whole number, because the farther you get away from 0, we call these smaller numbers. But I guess as far as size, you might want to say the bigger negative number. I don't know. It can be kind of confusing. You really want to use the terms the way the mathematicians have set the parameters. So the correct way to say it is the greatest lower bound. So it's the largest negative number that you have. As far as going away from 0, this is bigger. -3 is bigger than -4 because it's closer to 0. So the greatest lower bound, the biggest negative number that you get to, that is bigger than all your other zeros, or smaller than all your other zeros. And then on the right side, we go to 5, but 6 was our upper bound. So this number actually hits 5. It doesn't go past 6. So it kind of matches here. And well, it does match, doesn't kind of match. And that's what that property is for. So now we want to input our zeros. So we have 5, and then at the bottom, solving for x squared equals 5, we got positive square root of 5 and comma negative square root of 5.